Question 4. We have to show that this equation here has a solution between 0.8 and 0.9. And so we start off by looking at f 0.8, and we just feed that into the formula in the calculator, and I get 0.082. If I look at f of 0.9, that is minus 0.89. Okay, so we have a sign change between 0.8 and 0.9, and also this function is a continuous function. So therefore a root exists between these values. Could actually have more than one root, it's just saying that at least one root exists between these values, but that's what the question's asking. So it has got a solution between those values. Okay, part B now. Show that the x-coordinate of P is a solution to that equation. Well, what do we know about P? We know it's a minimum point, so at a minimum point f dash x must equal 0. Okay, so f of x equals x squared minus 3x plus 2 cos half x, and f dash x equals 2x minus 3, and we're going to be applying chain rule there, minus sine half x. Okay, so that actually helps us, because if you look at the formula we're trying to get to, that involves sine of half x, so that's looking hopeful. So 2 of x minus 3 minus sine half x equals 0, and that's at P. So how are we trying to get to that? So we look like we're going to have x on its own, so I'm going to get the 2x equals 3 plus sine half x. That means x equals 3 plus sine half x all over 2, which is where we want to get to. Part C is moving on from B. We've got the equation from part B is now going to be used as the iteration formula, as you see here, and we've been given x0 equals 2, and what the question wants us to do is find x1, x2 and x3, and it's wanting them all to 3 decimal places. So as we've done previously, first thing I'm going to do is define x and store x as 2. Then I'm going to write in the formula 3 plus so the formula is written in exactly as it is in the question. My first value is 1.921 to 3dp. Store that. That's stored as x. Back into the formula. 1.909, so 1.910 to 3dp. Store that. Back up to the formula for the last run through. 1.908. All to 3 decimal places. Okay, part D. Now just be careful with part D. We've got to choose suitable interval, show the x-coordinate of P is. Well, in this case, don't use the iteration formula. You need to go back here to the original differential, which is f dash x equals 2x minus 3 minus sine half x, because that's the differential. So at P it's going to equal 0, and so we find the upper and lower bounds. There should be a sign change. Okay, now it's asking us 1.9078 to 4 dp, so upper equals 1.90785, and the lower bound equals 1.90775. Okay, so those are our two bounds. Both of those, if rounded to, or anything below the upper bound, rounded to 4dp gives me 1.9078. Okay, so f of 1 point, or f dash 90785 equals, so I need to define x 90785, store that as x, and I'm going to put that into the equation. 2x minus 3 minus sine 1.5 x, and that equals 7.66 times 10 to the minus 6. Okay, let's have a look at f dash 1.90775. Store that in the calculator as x. Back up to my equation, and I get minus 1.634 times 10 to the minus 4. Okay, so as before then, I have a sign change between values, and looking at the function, it's just signed so it is a continuous function. It's a continuous function, therefore root must be 1.9078 to 4 dp.